Okay, in this video I'll continue where I left off in the first video for problem 3. And that was we're in part C, and we found that h prime of 17 is equal to negative 380.281 people per hour. And we're asked to find the meaning of h of 17, or explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. Well, h of 17 is going to give us the number of people in the park at time t equals at time t. And in this case, t equals 17. And that's at 5 o'clock. So h prime of 17 then, if h of 17 is the number of people in the park, h prime of 17 is the rate at which the number of people in the park is changing at 5 p.m. So h prime of 17, which turned out to be negative 380 people per hour, tells us that the number of people in the park is going down at a rate of 380 people per hour at 5 o'clock. Finally, for part D, we're asked at what time between t equals 9 and t equals 23 does the model predict that the number of people in the park will be a maximum? Well, first of all, this maximum is going to be an absolute maximum, and we do have a continuous function on a closed interval. Then by the extreme value theorem, there will be an absolute maximum, and it will occur at a critical value or endpoint. So I'm going to make a table. I'll start with my endpoints, which are 9 and 23. Don't start at 0. In this case, it only goes from 9 to 23. And recall that at t equals 9, there's no people in the park. There are no people in the park. We need to find the number of people in the park at time t equals 23 then. So I have my function e of t and my function l of t. If I want function h of t, then I'm going to have y1 minus y2, and that will give me the change in the number of people in the park between two periods of time. So if I go from 0 or from 9 to 23, then that will give me the number of people who are left in the park at time t equals 23, or the net change of people in the park, and since we start with 0, that will give me the number of people left in the park. And so I set my x values to go from 0 to 24 by 2, set my y values to go from negative 2,000 to positive 2,000, assuming that at most in 1 hour we'll get a change of plus or minus 2,000 people in the park. And I'm going to go to graph and I end up with a function like this. So I'm going to take an integral from 9 to 23. Start that again. Second, calc number 7, integral, lower limit 9, enter, upper limit 23, enter, and I get 1.014, which is roughly one person left in the park at time t equals 23. And so last one out turns off the lights. But I do see that I have a point where the derivative changes from positive to negative, so that will give me a relative maximum there. I'm going to clear draw, and I'm going to find that by using a 0, left bound 0, right bound 24, guess, and it gives it to me at 15.795. Now since we start with 0 and we end up with 1, then that has to be the absolute maximum, but let's find the value that we're looking for. I'm going to store that value of x. So store answer. I'm going to store x in A and go back to my graph, and I'm going to integrate between time t equals 9 and time A, and I'm going to get 3950.68, and that happens at t equals 15.795. Okay, so that completes this problem.